This is a thermal expansion tank, pretty basic. The front part right here, that has water. That's where it absorbs the water. In this thing right here, a diaphragm, that's a cutaway view. So you see that whole part, just that little part, that diaphragm expands to hold water, and the whole back of it is air. So we're using Boyle's law to increase the pressure of a gas, we reduce its volume, which is what we're doing, and we're mimicking that water pressure in our water pressure to our domestic side. Problem is so thermal expansion, as we heat things up, the molecules move apart. Same thing if they go cold, until we go to absolute zero. So if the guy puts his tongue on a pipe and it burns, they don't think about it, but that's a burn. That's because as things get colder, molecules move apart, and as hot, if they heat up, they move apart, just like in a frying pan or something like that. Well, with hot water, because we're inversing temperature to pressure, that's where it gets very, very dangerous. This absorbs that ancillary pressure, and every time it relieves it. So right now, you don't see any water coming back, right? Here's where it gets dangerous. When these diaphragms go, and they go all the time, guess what? This thing can fill up with water, and that's why the code now says, hey, you have to secure this to the structure, not, just arbitrarily hang there. Because while this one looks like it's certainly fine, as soon as I put a hole in this, you're going to see what happens. We have all that water, which it wasn't designed for, essentially being held up by a 3/4 inch pipe. So now let me get this dude out of here. And guess what? See how water's draining now? Well, the diaphragm, see how it's... Yeah, see there it's draining. It's airlocked, but this whole... There it goes. But this whole thing is full of water, massive weight that it wasn't planned for. Moral of the story, have to secure thermal expansion tanks to the structure. Need any help with this? Call the shop, we'll hook you up.